Hello, good evening.
Good evening, sir.
How are you?
We're fine, sir.
So, how many ayus are here?
So two.
Two ayus.
Yes, sir.
And what about the another one? Why do we have two here?
Agas. Hello.
Ah,
Hello.
yes, yes.
No, sir. I'm calling my friend.
Okay, leave him, leave him. Um, okay. So, should we wait for 1 minute?
Okay, sir.
And Sherpa, this is are you, is this your first day today? Hello, Sherpa. From your name, it's difficult to figure out. Is this the first day? We haven't seen you before.
Yes, sir.
Yes. Is this the first day today?
Yes, sir. It's my first day.
Okay. So where are you from now?
I'm from Sarmatang,
Where?
Young Rima boarding school.
So where is this? Where is this school?
It's in Helambu.
It's in Helambu.
Yes, sir.
So it's nice to hear a student from Helambu. So are you joining from Helambu now?
Yes, sir.
So how's the weather there?
It's very cold.
It's very cold. What's the
Yes.
temperature?
I don't know.
You don't know. So it's cold, right? Okay. Do you have school nowadays also?
Yeah.
Okay. So do you know what which subject is which class is this of?
Yes, sir. I know it.
Grade 10 compulsory math, right?
Yes.
Okay, so we have different classes assigned for different subjects, and this is for compulsory math. Probably you know that. And so you are from Helambu. So is your course completed in your school, Miss Serpa? Is your content, the book content of the books covered in your school? No? Okay, leave it. Rupesh Dungelji,
Hazır sir.
how is your life going on?
It's going smooth, sir.
It's going smooth.
Yes.
So, so just a minute, Mr. Rupesh.
Hazır sir.
Ani, so everything is fine here.
Yes, sir. Everything is fine.
So, what are you doing in your school nowadays?
Regular classes चालू रहा sir.
Regular classes from what time do you have regular classes?
From 10 to 4.
From 10 to 4.
Hazır.
No extra classes.
No extra classes.
No extra classes. That's great. That's great. Okay. So, Miss Sherpa, you are back. Are you back now? What happened to you? Can you hear us, Miss Sherpa? Okay. So last week we have completed circle and from day before yesterday, we have started doing parallelogram and triangle, which is also the part of geometry. And can anyone tell me, in area of triangle and parallelogram, how many theorems are there? We call it sin theorems. How many theorems are there? Main theorems in the book, not in the exercise, in the book, like theorem 1, theorem 2, theorem
Three
3,
theorems.
three theorems. Okay. So can anyone tell us which theorems are there? What kind of theorems do you have studied?
So theorem one is parallelogram standing on the same base are equal in
Are
area.
equal,
Yes, sir.
are equal in area. So Ayush bhai, did you come last time, day before yesterday here in this class?
Yes, I was there.
So I hope I
So I
think
came late.
you came late and you were the only one there, I think. There were other guests, so there were
Yes, sir.
unwelcoming guests. So
Yes, sir.
okay. So second theorem was about triangle and parallelogram, and the third
Yes, sir.
theorem was about triangles. They were standing on the same base,
Are equal in
and
area.
they were lying between the same parallel lines as well,
Yes, sir.
right? So
Yeah.
we'll quickly catch those three theorems, and we'll move ahead to the numerical problems as well as our theorems, right? So I hope you can see the screen. This is theorem one. Can everyone see the screen?
Yes, sir.
Okay. Now, Rupesh bhai, Rupesh, Mr. Rupesh,
Ajay sir.
do you see a parallelogram on the screen? One
Yes, sir.
parallelogram.
I see.
Okay, what is the name of that
Yes.
parallelogram?
A, B, C, D.
A, B, C, D. If I say it is A, B, D, C, will it be correct? If I say A, B, D,
No.
C, will it be correct? Why?
No, no.
Why?
यो एकदम उसमा हुनुपर्छ कि क्रममा क्रोनोलोजिकल अर्डरमा हुनुपर्छ त्यो
Okay.
चाहिँ
If I say A,
नाम
D, C, B, A, D, C, B, is it fine? Is it fine if I say A, D, C, B? Do we call it an order? Do we call it that the names, the vertices are in order?
यस
Yes. It should not jump, right? Either it can be in clockwise direction or in anti-clockwise direction, but it should be user friendly. Like if we have the name of the paragraph A, B, C, D, then it would be easier for students to remember, right? Or to read. That's why we usually write the name of the triangle or write the name of the parallelogram in such a way that alphabetically also it is in order. Like we have A, B, C, D, and we cannot say it is A, B, D, C because we cannot jump. Either we can move in the clockwise direction or anti-clockwise direction, but we should take them serially. Like our friend said, Rupesh said, we cannot say A, B, D, C. We can say A, B, C, D, or we can say A, D, C, B. Now, now, what's the base of this what is the base of this parallelogram?
AB.
It's AB. Okay. So many of the students, when even they are in grade 10 and ready to take ACE examination, they are confused how to write the name of the parallelogram and why to take AB as the base. Why not DC? All right. Now we will look here why we are taking BC, AB as the base of the parallelogram ABCD here. Now, if you look at another parallelogram ABEF, ABEF, Mr. Rupees, can you see the parallelogram ABEF?
यस सर
Yes. And what is the name of the base?
बेस एबी
AB. Now, I am confused here why I'm taking or why we are taking AB as the base of ABEF as well as ABCD. Why can't we take other parts as the base here? Why are we supposed to take AB as the base of both parallelograms? Is there any reason that we should take AB as the base of ABCD as well as ABEF? Anyone? Do you know the reason why we are taking AB as the base of the parallelograms available here, like ABCD and ABEF? Why can't we take other parts as the base of two parallelograms? Is it compulsory that we should take AB as the base? Any idea? Why are we taking AB as the base of both parallelograms? Why not other parts? We have four sides, right? In each of the parallelograms, there are four sides, but we are considering here that AB is the base of ABCD as well as ABEF. My question is, I want to be clear here that why my students think that AB should be taken here as the base of both parallelograms. Can I hear any reason for that?
Because AB is common in both parallelograms.
Yes,
Common
that's
side
the
in both
reason. Yes,
parallelograms.
yes, yes. So the side which is common in both parallelograms, we consider it as the base, right? Thank you very much. So that's the exact reason that we are considering here AB as the base. Otherwise, we could have taken AF, or we could have taken BE, or we could have taken EF, or we could have taken AD of another parallelogram, or BC or CD of another parallelogram, right? But here you can see that AB is the only part, AB is the only side which is common in ABCD as well as in ABEF. The reason is, that's the reason, that's the reason that we are considering here that AB is the base of both parallelograms, and we say here that A on base AB, the two parallelograms ABCD and ABEF stand, right? And now, if it is so, then the theorem is about parallelograms standing on the same base. So AB is the common base on which the two parallelograms stand. Now, lying between the same parallels, what does it mean? Lying between the same parallels, what does it mean? Can anyone explain why are we taking two parallelograms which stand on the same base and lie between the same parallel lines, or we call it parallels only also? So which lines are considered here as two parallel lines here, between which these two parallelograms stand or lie?
Line DC
AB,
and AB.
AB and
DC.
AB and CF, we can say, right? Because the parts, the smaller parts are also the part of the lines. So we can say AB parallel to FC or CF, between which the two parallelograms lie. Okay. So now we have to prove that the area of parallelogram ABCD is equal to area of parallelogram ABEF. Now you can see here three colors, right? Can you identify what are the colors here? What is the color which is in the middle part? Which color is
Dark
that?
blue.
Dark blue. We call it dark blue. Okay, fine. And this one is
Purple.
the purple. Very good. This one,
Light blue.
white blue. So you can pass the um, you can pass the test for the driving license because you will be test the color blindness. Okay, so it's useful for that also. Now let's go to the theorem. While proving this one theoretically, because we will not be asked to prove this one theoretically, we will be asked to prove experimentally and theoretically in case of circles, but in case of this area of parallelogram and triangles, we will be asked only to prove theoretically. So now, uh, how can be proved? How many methods are there to prove this two parallelograms, area of these two parallelograms equal? How many methods? Basically, we prove the two triangles, area of the two triangles equal by showing the two triangles congruent. All right. So how many triangles can you see here? Is it one? Is it two? Is it three? How many triangles?
Two triangles.
Two triangles. All right.
Two triangles.
So two triangles. So in these two triangles, can we show these two triangles are congruent, and by which we can show that the area of the triangles are equal? Can we say?
Yes, sir.
Can we prove these two triangles congruent?
Yes, sir.
Yes. So before showing the two triangles congruent, we have to recall how many tests were there to verify that the given triangles are congruent? How many tests are there? One, two, three, four, five. How many? How many tests are there which help us to prove the two triangles congruent? Otherwise, we have to measure all the parts, right? Three sides and three angles. That's not possible. So what we do is we take help of five tests, established tests, which help us to prove the area of the two triangles equal by showing the two triangles congruent. So can anyone recall and tell us in the class how many tests are there to show the two triangles congruent? Rupesh bhai, do you remember the tests, axioms? Okay. So if not, then we have RHS, we have SSS, we have AAS, we have ASA, and which one? Last. Anyone remember? We have RHS, right? We have SSS, we have ASA, we have SAS, we have AAS. So we have five tests which can help us to show the two triangles congruent. Now, which test can be verified here? If you look at here, the two triangles, AFD and BEC, which okay, this is the standard procedure of showing the two triangles, showing the two triangles congruent or proving the theorem. So okay, now the first one, can you see the first one is angle AFD equals to angle BEC. Can you identify AFD and ABEC? AFD and BEC.
Yes, sir.
Okay.
Yes, sir.
So next,
ADF equals to BC.
ADF equals to
BCE.
BCE. Same reason?
Yes, sir.
Same reason. Okay, but the lines, the parallel lines are different, right? Now AD equals to BC. What's the reason? Can anyone tell us in the class, what's the reason that AD is equal to BC?
Opposite
Opposite sides
sides
of
of
parallelogram.
parallelogram.
Opposite sides of parallelogram. Which parallelogram? ABCD, right? And now with these three equal parts, which test is verified? Is it RHS or SSS or ASA or SAS or AAS? Which test is verified? Which axiom, let's say? They are congruent, right? They are congruent. So which test is verified? Is it AS or RHS, SSS? Which one?
AS.
AS. Because
AS actually.
why not ASA? Why not ASA? Because my students usually get confused here. Which one to use appropriately, ASA or AAS? So you say that it is AAS. Why not ASA? What is the difference in AAS test and ASA test? What is the difference? Or there's no difference? Randomly we write AAS sometimes and we write sometimes ASA like that, or there is reason behind it. It's AAS because the side is not in between these two angles. That's why we say it is a axiom or a test. Otherwise, if the side was in between these two angles, then we could have called it ASA. So by AAS axiom, the two triangles are congruent, and the two triangles are congruent. If the two triangles are congruent, then their areas will be equal. And what we do after this is, because we have to prove the area of ABCD equals to area of ABEF, we add quadrilateral ABED on both sides of number 2 to get the required result. And hence we prove number 4, which is to be proved in the theorem. Okay. Anyone wants to ask anything here or add anything here? Nothing. If there is nothing, then we'll have to do the exercise. Okay. Can anyone try this number 7a? Can anyone hear me? Can anyone respond to me?
Yes, sir.
Yes, sir.
La. Number 7, 8. Very easy. Number 7a. What can be done here? Can you see and think for a while? How can you find the area of the triangle ABC? Okay, looking at the picture there, what is the relation between ED and BC? What is the relation between ED and BC?
3 times D equals to BC.
No, no, no. I mean, you can see here the symbol here. Can you see the symbol over here? What does this mean?
It's perpendicular.
Perpendicular, yes. So ED is perpendicular to BC, and with the help of perpendicular line, which can be considered as height, we can find the area of the triangle, area of one of the triangles here. We cannot find the area of the triangle ABC directly with the help of ED, but if we join here, if we do construction over here in such a way that you have a triangle BCD, then ED, which is perpendicular to BC, is can be considered or should be considered here as the height, and BC will be the base. Now, do we have the value of ED? Do we have the length of ED or DE, whatever you call it?
Yes, sir.
This is not vector, so we can either write DE or ED. That makes no difference. So what is the length of ED then?
4 centimeter.
ED is
4
4
centimeters.
centimeter, 4 centimeter. And what is the length of BC?
12.
12
12
centimeter.
centimeters.
So with these two values, can we find the area of BCD?
Yes,
Can
sir.
we find the value of area of triangle BCD, which is half times base times height? Base, half times base. What is the base? What is the base
BC
of
12.
triangle BCD? It's BC times height is ED. So we can replace the values. Base half times BC, base is 12 centimeter, times ED is 4 centimeter. So if you multiply these three numbers, what is the product?
24 centimeters square.
24 centimeters square. 24 centimeters square. So that's it. Or should we do something more?
So we should do more.
Yes. Now, what is the area of the required triangle ABC then? What is the area of the triangle ABC then? Anyone?
So 48.
Does 48? Why 48?
So 2 times.
Two times. Why two times? Therefore, area of triangle ABC equals to 2 times area of triangle BCD, and we should give the reason, valid reason for writing this one. So what should be the valid reason for doing so? Because why? Why can we write that area of the triangle ABC equals to twice the area of the triangle BCD?
Because D is the midpoint.
Because D is the midpoint, or BD is the median of the triangle,
BD is the median. Yes.
which bisects the triangle into two
Triangle.
parts, two equal parts. So we basically write here, as you said, you can say being, because D is midpoint,
D is midpoint and BD is median.
midpoint of, or better to write like this, I think. Better we write here. Better we write here. Better we write here. Because BD is
BD is the median which bisects triangle ABC into two equal parts.
is median of triangle ABC. So that's enough, because median bisects the area of the triangle into two parts. So 2 times 24 centimeters square equals, as our friend said, it is 48 centimeters square, right? So this is very easy number. Now let's go to number 8. Number 8. Anyone wants to try number 8? Anyone wants to help us how to solve this number 8 go A? Can you think for a while how to solve this number 8A? Anyone? Who wants to volunteer how to find the value of the area of triangle AEB? Anyone? No one. Okay, let's do the solution for 8A. 8A. Now, since we haven't given here, if we do formally, the solution would look like this. The process, the pattern of asking the question is different here, different this time for AC, but normally we solve the problem like this for this portion. So in the parallelogram ABCD, the area of AED, triangle AED, is given here, 16 centimeters square AED, and the area of triangle AEC, AEC, AEC is given here, 14 centimeters square, and you have to find the area of triangle AEB. Triangle AEB equals to what? So with this information, how can we find the area of AEB? So who is connected to triangle AED directly? More closely, who is related, let's say, in terms of geometrically, to triangle AED here? Is it the area of parallelogram ABCD?
Yes, sir.
What relation do they have? What relation do they have? Is it area of parallelogram ABCD. ABCD equals to 2 times of area of triangle AED. Can I write this one? Can I write?
Yes, sir.
And
Yes,
what
sir.
reason should I write here? What reason? Because,
On both are standing on same base and between same parallel.
okay, very good. So some people might say here, BC is not common in the triangle AED and ABCD. So how can one say that this triangle and parallelogram stand on the same base and lie between the same parallel lines? What is the answer you want to give to those friends who argue that the triangle and the parallelogram are not standing on BC? So how can we say that they are on the same base?
From AD. AD is the same in both. AD is same.
Yes. So that's the correct answer, right? So whichever part is common in both, we consider it as the base for both figures. So that's the reason that we say AD is the base for ABCD as well as for the triangle AED, because AD is common in both. So we can write here that they stand on they stand on same base and lie between the same parallel lines, right? Okay. So two times. What is the area of triangle AED? It's 16. So we get here 32 centimeters squared. 32 centimeters squared is the area of the parallelogram ABCD, right? Now, now, do you see any connection? Do you see any connection? Okay, now what next? How to find the area of triangle AEB then? We have been given here area of triangle AEC. Area of triangle AEC is given, which is this portion. This portion is given. The area of this portion is given, and we have to find the area of this portion. We have to find the area of this portion. So, how to find? Any idea? Can we say area of triangle ABC is half of parallelogram ABCD? Can we say? And people will ask here, what is the reason behind this? So can anyone suggest what reason should we write here for this statement? What is the reason behind this?
So theorem 2.
Pardon? Theorem 2? It's not theorem 2. Wait. So this is not theorem 2. What was in theorem 2? Tell me, what was there? Triangle in the parallelogram standing on the same base and lying between the same parallel lines are means a triangle is half, right? But but is AC a diagonal of the parallelogram ABCD? Is AC the diagonal? We usually don't give that reason, that theorem number 2. We say here clearly, we can see here that AC is the diagonal, and diagonal always bisects the parallelogram. So we write here the reason. We write that reason. AC is the AC is
Diagonal of parallelogram ABCD.
diagonal of parallelogram ABCD would be the best. Half times 32. What is half times 32? It is 16
16.
centimeters square. 16 centimeters square. Now at last, at last, therefore, AEB AB equals to triangle ABC subtract triangle AEC, right? AEC.
Yes, sir.
See. So ABC is 16 centimeters square. Subtract AEC is 14 centimeters square. So we get here how much? 2 centimeters square. . Okay. Anyone has anything to add in this number? If not, will you try 8B? Will you try 8B classwork now? Take 5 minutes time and think for this number. 8B, because unless you do, you will not understand. Okay. Did you get the answer of number 8B? Anyone? Got any idea?
Yes, sir.
Okay. Can you explain to your friends from there? We have been given here area of triangle A. Wait, let me just highlight over here because it will be a little bit clear for people to understand here. Area of triangle ABE is given. ABE means this triangle. Area of this triangle is given. Area of triangle CED is also given. So this is also given. And we have to find the area of BEC. We have to find the area of BEC. So you have to find the area of the triangle BEC as well as the area of the parallelogram ABCD. So it's very easy. In fact, how did you find? What is your idea?
Sir, triangle BCE is the half of the parallelogram ABCD.
Wait, let me write here.
Yes,
Then your friends will easily understand. Right? Okay.
yes, sir.
Uh, wait. Triangle. Did you mean triangle BEC? BEC is half of
Parallelogram
parallelogram ABCD, right?
ABCD.
Okay.
Yes, sir.
And then
So, and then triangle ABE and triangle ECD are the two
yes.
remaining triangles.
Uh, wait. Or can we do like this? Half. Can we write parallelogram ABCD as triangle BEC
Yes, sir.
plus
Plus
triangle
triangle
ABE
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 plus
plus
triangle CED.
CED CED CED, and this would be, wait, um AB ABE. Did you say ABE? ABE plus triangle
CED.
CED CED CED. And what is the reason for this one? Or without reason also we can write this one because this is all about breaking down this ABCD.
Yes, sir.
ABCD, right? Parallelogram ABCD. We have just broken down into pieces over here. This is whole part exam actually. Whole part exam means the whole thing is sum of the parts. So ABCD is always equal to the sum of the parts. ABCD, you can see in the picture that it is made up of ABE, BEC, and CED. That's why ABCD will be either equal to the sum of these three parts, or it will be less. It cannot be more. So that's what we call the whole part exam. Now we can find here 2 times of triangle BEC. BEC equals to triangle BEC is as it is. I've taken this 2 to that side.
Yes, sir.
Wait, not here, here. After this, plus what's the value of the triangle ABE? It's 25, right? Plus CED is 30. 30. And if you bring this triangle BEC to left side, you'll get triangle BEC equals to 25 plus 30,
55.
55 centimeters squared. So this is one answer, right?
Yes, sir.
This is one answer. And eventually we can find the area of
Parallelogram.
parallelogram ABCD from this itself, because we can use this one. Is half of ABCD equals to triangle BEC, and triangle BEC is 55 centimeter, which we have obtained just now. Therefore, parallelogram ABCD will be 2 times of 55. What is 2 times of 55?
110.
110, 110 centimeters squared, right? So,
Yes, sir.
so what was your original idea?
This only.
No, no, no. This was not your idea. This was a little bit my idea. So, what was your original idea?
So I was also trying to say this only.
I know that one, but you were saying remaining part and something like that.
Yes, sir. So then the both remaining parts will be equal. No, sir, not equal. Their sum will be the half.
Some will be the half. So you were doing in that way. All right.
Yes, sir.
Okay, that's fine. But if you follow the steps geometrically, then it would be easier to show, right? To
Yes,
verify
sir.
or give logical explanation. Okay. So we did number 8. What about number 9? This can be of 3 marks. Higher ability question. We call it higher ability question or application. This whatever the numerical problems we did, this one they can be taken as application problem. And this one, number 9, seem to be higher problem of higher ability. So what do you think? How can we solve this one? Number 9, go A. First of all, we should be able to draw the figure, right? In this in such particular problems. Now, how do you draw the figure? It's ABCD parallelogram, right? So normally we draw the parallelogram like this: ABCD, ABCD. I'm not using the geometrical instruments here, simply doing freehand drawing. AB, ABCD is the given parallelogram. And where is X?
So it lies
X
within
is,
it.
X is somewhere here inside the triangle, inside the parallelogram, and we have to prove that the sum of triangles XAB, and XCD, meaning you have to join these points, even if it's not said here, it's not mentioned over here. We simply have to join these points, because unless we join these points, the triangles will not be formed. So we have to join these points, and we should not forget that these are not straight lines. AC is not a straight line. BD is not a straight line. A and X are joined. BX is drawn, XC is drawn and XD is drawn, right? Now, so in given, we can write here ABCD is a parallelogram where AD is parallel to BC and AD is parallel to BC and AB is parallel to DC, right? And to prove is to prove is triangle XAB plus triangle XCD equals to half of parallelogram ABCD. It's all about area. Now, do you think we need any construction here? This is a very easy problem. Do you think we need any construction over here? Anyone out there? If there's anyone left in the class, Miss Sherpa, do you think we need construction which will help us to solve this problem? Okay, simply what you do is you join here, you draw here a line which is parallel to AB, meaning it will be parallel to DC as well because ultimately AB was parallel to DC. And the line which you draw here parallel to AB or DC will be parallel to both. So what we can do here is let's draw here a line PQ which is parallel to AB and CD. Even if you don't mention this, if you say let's draw a line PQ passing through the point through X parallel to AB, it will automatically be parallel to DC also. But if you write here that let's draw here PQ passing through X parallel to AB and DC, it would be better. So now if so, then can you see any relation between AXB and okay, first of all, tell me, is PQBA a parallelogram?
Yes, sir.
Okay. Similarly, is PQCD another parallelogram?
Yes, sir.
Yes.
Yes, sir.
So this is very easy, right? Okay.
I got it.
Very good. Triangle XAB equals to half of parallelogram ABQB. Reason you can write yourself. Number one. Number two, triangle. Whatever the name is given over here, if you write it in the same order, it will be easier to prove. So I usually take that one and use the same vertices in the same order. XCD will be half of P parallelogram PQ CD, and after adding this XAB and XCD, you will get here half coming common, and and what is left in the bracket? AB AB
ABCD.
UP plus parallelogram PQCD, which will ultimately give us parallelogram ABCD, which we have to prove. Right. Now, if you can take the picture of this one, take the picture and try these numbers. Is it fine?
Yes, sir.
Okay. Then have good time. Good night, everyone.
Good night, sir.
Right, sir.
Good night. See you.